Section 4.6, Part 1 is about solving rational equations. Some prerequisite skills we're going to need for solving these rational equations is going to be able to find the least common multiple. All right, in this case it says find the least common multiple of 2a, 2ab squared, and 12b. If in case you forgot, you can sure look up this site, and I'll post this up on the website as well. But that it gives a nice explanation, but I can also show you here. In this case, what I'm going to do is I'm going to break everything down and write as prime factorization. Well, I know 2 is prime, and I can't break down a any further. That's 2a. 2ab squared breaks down 2 is prime, a is prime because there's no other factors of a, and then b squared can be broken down into b times b. And then 12b can be broken down into 3 and 4. Sorry, there's a b there. 3 and 4, this is prime, so circle it, and then 2 times 2. So overall, this can be written, its prime factorization as 2 times 2 times 3 times b. And then in order to find its least common multiple, what I do is I write it out in columns. So 2a was broken down to, I'm going to have a 2 column, and somewhere over here I'm going to have an a column. Okay, and then for 2ab squared, I'm going to go ahead, I'm going to fill my 2 because I have a 2 column, I have an a column, and then I'm going to need 2 b's. I'm writing their prime factorization. I'm writing what I got up here in the columns. And then for 12b, I had a 2, and then I had another 2, and then I had a 3. I didn't have an a, but I had one b. And to find the least common multiple, all we do then is take 1 from each column. And that'll be its least common multiple. So take 1 from each column. So I'm going to need a 2 times 3. So one of these from each column times an a times a b and times a b. So my least common multiple is 12ab squared. All right. In this case right here, this x minus 3 is already in factored form. It's in prime factorization. We can't reduce that thing any farther, so we haven't, sorry, not a's. I was in the habit of writing a's earlier. We have a x minus 3. And then in this x plus 2 is also in factored form, so I'm going to have another column, x plus 2. So here are my columns so far. And then this one I can pull an x out. I can pull an x, and I have x out in front and x plus 2. So this one breaks down into an x column. I'm going to put that out in front. And it breaks down into then an x plus 2, so we can fill it in this column right here. And again, take 1 from each column. So we need an x times an x plus 3 times an x plus 2. So that is the least common multiple of these 3. Last one real quickly, x minus 1 is factored fine. So we have an x minus 1 column. We're going to have an x plus 1 column. This one's factored completely. This x squared minus 1 is the difference of perfect squares. It can be broken down into x plus 1, x minus 1. So then it looks like I'm going to have an x minus 1 here to fill in that column, and an x plus 1 here to fill in this column. Pull out 1 from each column. I have x minus 1 times x plus 1. And that's the least common multiple of that. For the reason we're doing this is when we're solving rational expressions, we are going to have to get common denominators in order to solve. All right, so here we go. Example 1. Solve this rational equation. All right, t plus 4 over t plus 3 over t minus 4 plus negative equals negative 16 all over t squared minus 4t. All right, so what we're going to do is we're going to have to find a common denominator for each of these guys in order so we can add like terms. So in order to add these fractions, just like if we had 1/2 plus 3/4, we can't add these two guys until we have the same denominator. Same thing here, we can't add these guys until we have the same denominator. In the same sense, we can't take this over the other side and combine it with something like this because it doesn't have the same denominator. So let's say I had 1/16. I can't subtract 3/4 over here until I have a common denominator. All right, so we're going to have to get a common denominator first. In order to get that common denominator, again, we're going to have to find the least common multiple. In this case, I have a t, then I have a t minus 4 column. That's in factored form. And then it looks like this one, then I can pull a t out, and I'd have t, and then one left over I had t minus 4. That would give me t squared minus 4t. All right, so take one from each column, and my overall denominator is going to have to be t times t minus 4. And in this case, it already is that, t times t minus 4. A lot of times it helps to factor out the denominators so that you can see what you need to multiply your other terms by. So this term, it already has a t in it, so it's missing this t minus 4 component. So t minus 4, we need to multiply that by t minus 4. And we know how to multiply two binomials. We just have to FOIL, or you can notice this is a difference of perfect squares, but I'll just FOIL it out just in case. T times t is t squared. T times a negative 4 is minus 4. 4 times t is plus 4, so I have a minus 4t plus 4t is 0. And then I have a 4 times negative 4, which is negative 16, so I have negative 16. Okay? And then so this term, we're done with that guy then. This guy is missing, it already has a t minus 4. It's missing a t. So we're going to have to multiply this top by t. So plus 3t. Why is it plus 3t? Because of this sign right here. If we had a minus sign here, we would have to put it in parentheses, so we remember to cross the line and change the sign. Anyway, this guy isn't missing anything. It has both a t and a t minus 4, so we're just going to leave it. All right, now all we have to do to solve this equation is just to, now that we can add like terms, all we're going to do is we're basically going to forget about the denominator. And the only thing we have to worry about later is whether that can be a solution or not. So once we get to the end, we're going to plug that in. And you've known from all our graphing and stuff that stuff in the denominator cannot equal 0. So once we get our solution, we just have to check real quick whether it can be a solution or not. So if we get like 4 or 0, we know that that can't be a solution because it's going to make the function undefined. And we'll just check that at the end. So we're going to set the numerators equal to each other. So we're just going to forget about the denominators for now. So I'm going to move over to the left here. I'm going to have t squared minus 16 plus 3t, and that equals negative 16. All right. Well, we have options on what we can do. Let's go ahead and rewrite this in descending order. 3t minus 16 equals negative 16. What we can do is we can either complete the square, we can bring this over to the quadratic formula, we can bring this over, we can factor. Let's go ahead and let's start by bringing this negative 16 to this side. So I'm going to add 16, add 16. When I add those, they cancel out. So I get t squared plus 3t, and that equals 0. It's nice when that happens because I can pull a t to the outside. And I get t plus 3 equals 0. And then we just set both of these guys equal to 0. So t equals 0 and t equals negative 3. Well, like I said before, we have to check our solution and check whether it can be a solution or not. However, we found out earlier that 0 cannot be a solution because it makes this equation undefined. So therefore, we throw that guy out, and our solution is t equal to be negative 3. Example 2. Solve this. Okay, again, we're going to have to get a common denominator. Let's go ahead and let's factor this guy out. Let's see here. In order to factor this guy, I'm going to have a minus t out in front. And I'm going to have a regular t here, right? And then let's see, my signs are going to have to be different, plus and minus. I'm going to have to play around with this a little bit. They have to be multiplied, so it's going to have to be 7 and 2, but I got to play around with my signs a little bit. So 7 and 2, let's see if that gives my result that I want. So I get a negative t squared, and then I get a positive 2, and then I get a positive 7. And then I'd get a negative 14. So that's going to be that thing factored. I just had to play around for a little bit. So that thing is factored. We could also rewrite this thing as a negative t plus 7, by the way. and this is t minus 2. So if you notice, our least common multiple over here is negative t plus 7 and t minus 2. That guy, I'll go ahead and write it out for those of you that like the column method. This guy's factored already, so t minus 2. This guy's factored already, so 7 minus t, or if you're weird like me, I like my variables on the left side, so negative 7 plus, or negative t plus 7. And then this one can be broken down. One goes into this column, negative t plus 7, and one goes into this column, t minus 2. We take one from each column, so it's going to have to, our least common multiple is t minus 2 times negative t plus 7. All right. So that's going to be our least common multiple, and it's going to be our denominator. So t minus 2 and negative t plus 7. And of course, again, it just so happened in this example, this also worked out where this is, it's not always going to be that case, but this is also, this is already, we're not going to have to multiply it by anything. It already has everything it needs. So negative 7, or negative t plus 7, I keep saying that. And then t minus 2. And again, this guy is missing a negative t plus 7, and we're going to multiply that through. So I'm going to get, if I FOIL that 1 through or distribute that 1 through, I get negative t plus 7. And then it's going to be plus, this guy is missing a t minus 2. So I'm going to have to FOIL that guy out. So I get t squared. Then I get a minus 2t minus 3t is minus 5t. And then negative 3 times a negative 2 is a plus 6. And in this case, this one was not missing anything. It already had its least common multiple in the denominator. So we're going to leave it. And again, all that's left to do then is set the numerators equal to each other and we'll solve. And then the last thing to do is just check whether it can be a solution or not. So I'm going to have negative t plus 7 plus t squared minus 5t plus 6 equals t plus 1. Let's get everything to the same side and combine like terms. Here I'm going to get a negative t minus 5t is a negative 6t. And then I have, let's see, I know I have a t squared. I'm going to write that on front. So my t squared is gone, my negative t and my negative 5t. 7 and 6 is plus 13. Then I have t plus 1 over here. Again, let's get everything the same side. So I have t squared minus 7t, let's see, plus 12 when I subtract that over equals 0. Again, we have options. Can we factor this thing? Do we want to do the do the quadratic formula, or do we want to complete the square? Or if we can think what multiplies to be 12 and adds up to be negative 7, we can factor this thing really easily. And we're going to both need t's here. And this is telling us the signs are the same. They're both different. So the signs are the same. They're both negative. And then 3 times 4 would give us that thing factored. And again, set both of these guys equal to 0. T equals 3 and t equals 4. Those are our two solutions for that problem. And it doesn't look like either one of those makes this equation undefined. So those are both solutions for this equation. That, I believe, is all for this section. I hope this helps. We'll see you in class.